Good after, well, no, I guess it's still good morning. Just seems like it's been already afternoon. Welcome to the third of Cisco's 4 sponsored track sessions today. I'm just going to do a quick introduction of our presenters and get things off. Chandra Ganguly, one of our Director of Engineering within the Cloud Group. Ian Wells, one of our distinguished engineers. And they're going to be making cloud work for telcos from core to edge. Gentlemen,
thank you.
Have at it.
Thanks, Gary. Good morning, everybody. Here, I would like to introduce a little bit more, give a little more background of Ian. Ian is my cloud architect, and overall engineering director is me for this platform called CVIM, Cisco Virtual Infrastructure Manager. So we interchangeably talk about CVIM or Cisco VIM, both of them mean the same thing. What we're going to talk about today is the lay of the land, where the product is today, and what we see are some of the challenges going forward, and how we are addressing some of those. These are real challenges, because now that the product is selling, we have real customers who are actually deploying it in decent numbers. So some of the challenges we are seeing, we are actually proactively trying to address them as we go forward. So we'll talk about how this cloud has evolved and what we are going to do. Before we get into those details, let's talk about a little bit of how the cloud itself, the whole solution has evolved. So this is your classical telco infrastructure. You have everything in hardware assets. People are virtualizing it at various points of presence. Depending upon the size and scalability, they're virtualizing based on either a bunch of servers in one location or a very, very small set of servers building a cloud at the edge. So based on scale, you can have anywhere from a full-on cloud to a hyper-converged cloud to a micropod at the very edge. The main goal here that we are trying to do is through our platform is, doesn't matter how big or how small that cloud size is the same software that should be able to drive the scale, various deployment patterns. So one of the main tenet of our solution is it didn't really matter whether you had a full-on at anywhere in the point of presence or a microcloud micropod at the edge. It will be the software offering that will do this. It's just a matter of a config in the intent file that we have that will drive that. Also, one more thing that we want to make sure is our goal here is complete, full one-touch automation. Meaning there is no manual intervention, not only on the day 0 deployment, but also day in, whether there's a software bug because of some security issues like Meltdown or Spectra, or whether there was a true OpenStack bug, or we brought in a feature because we wanted to scale better or add in additional feature. The idea is it is all one-touch deployment, one-touch automation. Even if a hardware went bad, to take that compute node off the cloud, it is a one-touch. And there's no manual intervention. And I truly, that's the paradigm on which this product has been based. As we go through this year, we'll also talk about what are the current, or what are the problems we are seeing in the immediate 6 to 9 months and how we are addressing them. Yeah.
Okay. So I think the way this is going to end up working is Chandra is going to talk about the what we do, and I'm going to talk about the why we do it. And one of the things we're looking at here in service provider is you've got an enormous footprint. You're a service provider. You have a network that stretches for hundreds or thousands of miles across your country. And you want to use the potential of that. From the core to the edge, there are locations where you can put a cloud in your service provider network to deliver services that nobody else can do, whether they're network or other. You can get close to your customer. You can get much closer to your customer than Amazon is ever going to get. You can get in the path between your customer and the internet to offer value-add services over the course of their connection. But the problem is, as we move from core to edge, and you want the accessibility of all of those locations, then being in the core means a relatively small number of relatively large clouds, maybe 10, as you find it in your peering points or somewhere in the relatively natural path of traffic. But as you get to the edge, you end up with a large number of really small clouds. Now, that number actually varies, and that previous diagram gives you some clues as to how it can. If I'm talking about, as I say, peering points, then quite often there's rather more than 10 peering points in a country. But if I'm going out, further into, for instance, a cell site network, then I might be looking at 100 or even 1,000 sites where my cell site connections are pulled back, but I might be looking at 10 or 100,000 sites if I'm looking at the bottom of a cell tower. And there are uses to all of these, and quite honestly, the use cases keep coming up, the ideas keep coming. We want to be flexible with providing infrastructure that could be used for any of these things ultimately. So the problem with centralization distribution is people argue about how many clouds that actually means. So theoretically, at least, one cloud is not one location. I can run a cloud, I can run a control plane. We've had this discussion, one control plane where I'm running my compute nodes in lots of different locations around the network. So that's one option. But it has a number of problems. One is that's just not what Openstack was built to do. Openstack was built to be a cloud where all of my compute nodes are roughly equivalent. I can pick any of them to run a workload. If they're all in different locations for a reason, then this isn't a cloud anymore. But another more important one is that's not a use case that anyone builds Openstack to do. It's not a use case because everybody expects their cloud to be in a data center in a handful of racks, well located together, nice and tight, low latency, good reliability of connections, nice and high performance connections, and consistent performance as well. We'll talk about that in a moment. When you distribute OpenStack out into the wild, then you will suddenly discover that 90% of the people working on OpenStack are not building for your use case and will not test to make sure your use case still works. Whereas if we go for individual clouds in those locations, we have some attractions there. Autonomy and failure domains, they go hand in hand. I pretend to be, I am the master, and I just tell them what I want them to do, and I leave them to get it done. And if I'm not talking to them for hours or days at a time, they will get it done. That's fine. Failure domains, as I say, it's best if the entire country doesn't try and pick up the phone and call your support line at the same time because their internet has gone out. It's nice if that doesn't happen all at the same time, and you tend to hear it on the national press when it does. So keeping your failure domains small so that they can actually be each other's backup works very well as well. But if you do this, your problem is that now you've got your clouds scattered in little cupboards all over your network, and now you have to ask yourself, how am I going to manage that? How am I going to deploy that? How am I going to repair that? How am I going to deal with that whole thing? So is there a middle ground we can deal with? How do we keep the management central, deal with this from my network operations center while having my clouds distributed around the network? And so that's a model we're trying to work with. We've talked about this, right? Distribution of compute nodes looks good, but it doesn't really work. And one of the bigger things where it doesn't really work is imagine you're upgrading your cloud. Your cloud is now your entire network. You can have a maintenance window, but a maintenance window that takes your whole network out for 8 hours at a time is not a maintenance window that anyone's going to approve. So that's an issue. Again, the more interesting thing here is to deal with the multiple clouds, but actually deal with them from a central point of management that deals with them together. So what I'm trying to do is deal with, for instance, rolling upgrades of individual clouds across a network, management of clouds so that despite the fact I'm deploying many clouds, I'm deploying them to a common pattern, so I'm getting the same results in all of my locations. This is the kind of thing that we're trying to deal with here. We're trying to bring the management of clouds to the center, but leave the clouds out near the edge. And a quick word about SDN in a world that involves a WAN network. And this is what I was intimating a little earlier is when I'm dealing with a cloud, then a cloud has its own properties. A cloud has its own SDN because its networking is relatively predictable. It's all in a small footprint with a top of rack at the top. But the issue, and it has a bunch of standard APIs, and those standard APIs are necessary. But what I really want to do here is I want to divide that cloud off from everything else in the network. WANs have different properties. I would want to do traffic engineering over a WAN. I certainly expect there to be higher latency over a WAN, and the cost of bandwidth on a WAN is very different. I mean, I can't just assume that I've got 10 or 40 gigs from point A to point B in my network. So I'm dealing with a wholly different set of properties of the network. So our theory here is, again, that if your clouds are well contained and in a location, they should have their own SDN controller that looks after their domain. The WAN may have an SDN controller, it may just have an operations team, it doesn't really matter. But these things need to cooperate. They don't need to be owned by one SDN controller that rules the world. And if they were, again, the SDN controller would become a common point of failure. So the trick here is to get these things to cooperate, to deal with each other over conventional networking protocols. The cloud is just like a router in a network. As long as I'm talking BGP, as long as I'm talking normal protocols, I'm just a component within the network. And then I need to orchestrate it so that it plays well with the network. I tell the network and I tell the cloud what I want them to do at the same time. I tell them their piece in the puzzle, and I leave them to sort it out. Again, this is a model that works well with service provider networks, that an overall architecture of one cloud, one SDN controller can't deliver. So the challenges we end up, again, we've pointed out some of these things, is if you don't have one touch, one button install and management, then you've got a problem. It's not about, I mean, everybody is used to this. We've all done this for years and years within the OpenStack community. You deploy a cloud. 5 years ago, certainly, it was a miserable, miserable experience because you deploy a cloud and it didn't work, and you deploy it again and it didn't work, and you deploy it a third time with a slightly different set of settings and it still doesn't work, and eventually you get to a cloud that works, and then you try the same configuration with a second deployment and it doesn't work. So one-touch deployment, people think about it as installation and getting the installer right, but I think we've got to the point, well, we've certainly got to the point where the installer is right. We test it nightly, in fact, on every commit to make sure it's right. But this isn't about getting the cloud up quickly the first time. This is about getting the cloud up repeatedly every time. And that's far more significant when you're deploying hundreds or thousands of instantiations of that cloud. It's got to be consistent because it's got to behave the same. If it behaves differently in location A and location B, or in location A and in your lab when you're trying to reproduce a problem, then you are never going to get anywhere. That's the sort of thing that gets you to a cloud that you can operate with a team whose interest is not in operating the cloud, but delivering services over the network. We also think that API-driven mechanisms of things that you don't consider for APIs are significant. So deploying and upgrading and repairing a cloud, these aren't things that have OpenStack APIs, because that's what OpenStack is. At the end of it, you get OpenStack. But these are things that need APIs of their own, because again, dealing with 1,000 clouds, I am not going to press a button or type 1,000 commands. I'm going to basically press a button on ideally a user interface on a website that upgrades 1,000 clouds in a staged manner for me, because I want this to be automated. So dealing with that, dealing with API-driven mechanisms to do deployment is significant, and also dealing with the fact that actually you'll have multiple versions of the cloud in production at the same time, because your clouds don't automatically go from version 1 to version 2 at the push of a button all simultaneously with no outage and no pause. You do it phase by phase because you want to stage this to make sure you deal with problems. Again, we need to centralize the operations. It's not the cloud needs to be central, it's the operations need to be central. People in a network operations center need to be able to control their network. I don't need one person standing by a router in my network, and I don't need one person standing by my cloud in a network. And we need to be able to keep the footprint of the cloud down, and we'll be talking about that again in a moment. If I am running 100 clouds, and each 100 of those clouds needs like 3 storage servers, then that's 300 storage servers I'm paying with and quite a lot of disk. If I'm running 1,000 or 10,000, then that becomes completely unaffordable very quickly. So we need to understand that bigger clouds for central locations and smaller clouds for the outlying locations are going to be the norm. It's a perfectly expected thing.
So given that context, what have we done? Essentially, what we have said is we'll focus on the IaaS part. What we do is we will give you a cloud, which a consistent cloud across any site, that essentially on which you can run any VNF as long as they talk OpenStack APIs. That is the net premise on which we are developing this. So to do that, what is the underlying infrastructure? So you have a bunch of hardware, and you get some OpenStack open source bits. In our case, we take it from RHEL. But then that's where the interaction with any other third party or an upstream stops. There's a bunch of additional things that you have to do to get a fully packaged software, which we call Cisco VIM. What does that entail? Not only do we have to figure out that there's a day 0 install, with HA, with redundancy, with security, all of that has to be embedded as part of the curated system. Also, if we have it has to be designed in such a way that monitoring, any update, upgrade, reconfigure, lifecycle management of the cloud has to be included as part of that. We also had made sure that as part of this, offering integrated tests are there. That means once the cloud is installed, you can at any given time on demand run a control plane and a data plane test all the time through REST API. And it will give you TCP UDP data at a TCP UDP test case level with various packet sizes. Also, the cloud has obviously APIs which the VNFs are going to use. We also have made sure there's an integrated tool called Cloud Pulse. Some of this we have also upstreamed, which basically gives you if the APIs are all live. We also have a thing called Cloud Sanity, which again, through an API, you just run that and it will tell you not only the cloud APIs are good, even whether the nodes are reachable, whether the OSDs are in right shape, whether Ceph is properly. So based on the offering, whether it's control plane, computes, or storage, all the sanity checks are also done and again offered through a REST API. So essentially what the value proposition in this platform is not just taking a bunch of hardware or a bunch of open source components, bringing it all together, and the theme here is management of this whole entire cloud day zero day, and that's the theme, that's the value that we are trying to offer. Now, as Ian had rightly pointed out, footprint and cost are very important things, because when you have hundreds of this, you can't go to every site and say, 40 compute node with dedicated storage is the only way to go. There are cases on the edge, very edge, where the footprint is extremely, extremely important, like a 4RU box. So what we have is a full-on where the compute, control, storage are all dedicated, have their own resources, have their own hardware associated to that, to a hyperconverged where the storage and compute are coming together, to what is called a micropod, where the compute, control, and storage are all together, and you can expand it with additional compute if you need. Again, from our software point of view, there's no software just knows that, okay, this particular cloud, the intent is a micropod or this kind of full-on. That's all it knows from an intent file. And it doesn't treat, the software doesn't treat any of these pods any differently other than from a REST API point of view, from the management point of view, from a feature availability point of view, all of them are uniquely the same. But this does address the issue of, as we get into the edge, how do we address this humongous hardware cost that any of our customers will incur? One of the theme is management. So obviously, Ian, go ahead.
Oh, it's me, is it? Okay. Yeah, so, and again, right, what we're talking about here is trying to bring those clouds to you, but without having for you to touch 100 or 1,000 clouds at once. And so what we have is a model of unified management, which is the idea that we put a deployment in your NOC, not of a cloud, but of a management system that allows you to deal with having 100 clouds around there, looking after them, monitoring them, and dealing with the faults and the logs and the alerts that you're going to need out of them, but dealing with the software versioning of the upgrade, of the repair, because 100 clouds will have the occasional failed server in it, and you need to deal with that as well. So this is basically a deployment intended to bring the management intelligence back to you, to the NOC, to your work, but leave the on-site intelligence of the automated system, of the workload, out to the site that it needs to be in. And so one of the things here is the evolution rather points itself out at this point. What we want to do is bring more and more of this back to the NOC so that we can get rid of some of the hardware footprint. Today, as we're doing this, we deploy an extra node in the site which deals with some of the logging, some of the monitoring, log storage, and a few other things, and also deals with deployment operations. Now, that's great, but it's expensive, and it's more expensive as you move into smaller and smaller deployments. It becomes a bigger proportion of ultimately what you're deploying out in those sites. So one of our things that we are working on right now is to pull that out of the on-site location, to be able to deploy across the network reliably without having to have on-site management hardware exclusively to do management functionalities. And that means that we'll also be pulling other elements of the management out, so logging, monitoring, metrics, and alerting. As they're pulled out, as they're brought central, it also gives us more power to deliver to you correlations between sites, where something that doesn't look like a problem in a single site can be correlated with other parts of your system to understand that, in fact, something's wrong with your network in a more subtle manner and there's something to be dealt with. And this is something, again, that we need to make work with multiple clouds and multiple cloud types and software versions. So, software versions, again, you're not going to upgrade every single part of your network simultaneously, because that's honestly terrifying. All of a sudden, all of your software has changed. Does it work? If it doesn't, you have a big problem. But cloud types is significant. At the moment, we're talking about edges with NFV as we recognize it, which is a virtual machine-based NFV, but it's clear that containerized NFV is coming. When we've sorted out the questions of how we do packet-by-packet fast networking in Kubernetes, we will be deploying containerized NFV on the edge to do mobility and other edge-related functionality. And we need to be planning towards that. So this management that we're working on here is not exclusive to simply managing OpenStack. It's intended to manage any deployment that allows us to put workloads at the edge. And that single interface remains regardless of what deployment we're doing. We need to be able to deal with the edge functionality as if we've got 100 or 1,000 points to deploy anything. We don't care what they are. And we need inventory management, so we need to be able to deal with individual servers on the cloud for the case when a human actually needs to identify the server. And we need inventory management so that the orchestration that actually drives the applications out the cloud can actually work out what it's got to orchestrate on. So inventory management has to be pulled in there to kind of address that. So in summary, we want to say that edge is a solvable problem. It's not a solved problem. It's a problem we're trying to solve. And it's a problem that we have a good handle on at this point. Even when we're dealing with centralized deployment, edge certainly brings new challenges, but they're not challenges beyond the reach of what we can do. Ensuring your applications run in that edge is only one part of the puzzle. Operations is equally as important. You can spend so much more on simply operating this platform. And the platform itself is not what you're trying to deliver. The service is what you're trying to deliver. So we need to deal with operational overhead, which is a sneaky little thing that creeps up on you as you've got your deployment ready and then you try and hand it off, derailing your plans with costs and complexities and impossibilities of management, which you need to be addressing up front and which we hope that our platform addresses for you. So we are trying to create a cloud infrastructure for service providers that's built to scale as the edge itself becomes a reality and the scale is driven.
So that pretty much covers our talk. Questions?
Do we have any questions? Oh, okay. We're gonna try to get the questions on the mic so they get it for the recordings.
So, what sort of telecom applications would require thousands of edge computing nodes?
Well,
why not maybe one in every city?
Yes, it's a good question actually, and I'm going to apologize and say that I'm not the most imaginative person in the world, and some of our customers are, unfortunately. So they're the ones that come up with some of these use cases. But I mean, simple things like pushing out, particularly mobility as 5G comes in, mobility applications to the edge is becoming significant. But there's other aspects of virtualization which also come in, such as virtualizing the cable modem termination systems, for instance, or BNG, that also suggest that you're going to shove these things out further and further towards the edge. But the biggest question here is how many cities are there in the United States? There's a lot of cities to be covered. It's still going to be hundreds of deployments when today that's not where we are.
So I will tell you right away, we have a customer today in the United States only. They had planned to go with 140 sites. And they've already done about 90 sites. And they're struggling because every site they have to go and manage this themselves. So maybe it's not thousands today. Even today's scale, I already have a problem at a scale of hundreds. And this is a real problem. And this is a customer who's already paid us. So that's where we are today.
Any other questions? Well, apparently you've solved all problems.
That's our job.
Oh, there we go.
Some of your slides had a little Red Hat logo on them.
Yep.
Yeah, what's going on with that?
So what we do with our product is We build our own deployer and our own, layered stuff on top to make sure this is a manageable deployment. But within the product, we use an embedded copy of Red Hat, both the Linux kernel and the operating system, and the OpenStack packages. And we do that so that we're working on a platform where we've got good support, where we've got a guarantee of good quality before we begin to build the platform that we're trying to deliver to customers.
But that doesn't imply anything about my NFVs that I want to run.
No, you run whatever you like. These are virtual machines. You put in it whatever you want to put in it.
So our philosophy is slightly different. We will put our resource and effort on the problem that has not been solved rather than a problem that has been solved. In the case, what we have taken is we have taken the RHEL bits and the OSP bits from Red Hat, and that's basically where we stop the interaction with Red Hat. But how we deploy it, how we make sure it can be updated, upgraded, all of that is our problem, and I think that's where the value lies. However, given our relationship with Red Hat, if we identify a problem, and if we know what the root cause and how to solve it, we have our own CI/CD system on which we overwrite Red Hat packages with our fixes. So we are not waiting for Red Hat to actually fix that problem. We, in fact, what we do is we turn around and give it to Red Hat saying that here is how we have solved it. It's up to you whether you take this solution or later on when they come up with a better solution, we'll just take it in our monthly repo update. That's our whole CI/CD system.
Thank you.
You're welcome.
We have one more.
Hi, thanks. Oops. Some of the conversations around edge deployments are beginning to look at these resource pools as not only locally relevant but potentially sharing between pools or pods. And so I guess the question is, have you started to think from your guys' point of view about, well, what if I need, what if I'm trying to be thoughtful about share, how much resource I put out there, and might I need to take advantage of storage in a nearby node rather than going back?
We've certainly given some thought to that. It's a little complicated because if you're trying to make your infrastructure as interconnected as one stealing storage from a nearby location, you get to that point of common points of failure again. And the infrastructure being your building block, your foundation on which you're building, it's one of the things where things are best kept segregated if you can possibly manage it. But it's certainly possible to write an application that understands that multiple locations and multiple clouds are at play. So our feeling, my feeling, let's be honest, right now, is that that's a better solved a level up where the application can make best judgment in terms of what service it's going to deliver, and the infrastructure can provide a concrete guarantee of what service it's going to deliver, where the integration can leave you with open questions about, so how fast is this storage? If the storage is over there, it behaves quite markedly different from if it's local, for instance.
Right, yeah, fair enough, yeah, thanks.
Okay, this one is more talk about the deploy, like extending the VNF into the edge. So we want to know what the Cisco's positions on the universal CPE, because you are traditionally offer all of the CPE devices at the branch offices. So is this one moving toward to the universal CPE model, or?
This is a platform. If what you want to run is a universal CPE, then you're welcome to. We have a slightly, how do I put this? We have to remain at arm's length from our VNF groups within Cisco. We have to work with them. We encourage them to test their stuff on our platform, and we occasionally test their stuff on our platform ourselves. But we have to work with third-party VNFs, and we have to deal with whatever comes our way. That's just how life has to be. So if you want to run a universal CPE here, be it a Cisco product or somebody else's product, you're welcome to do that. We haven't built it with that particular intention. We've just built it because that, among many, many other use cases, is a reason why you might want to deploy clouds out at the edge.
So one of the things what we do along with that is all those VNFs have various requirements. Some may have SRIV, some may have, may need, huge pages or CPU pinning. We've actually worked with all those various VNFs to make sure the platform has that offering. So again, we have one intent file where you decide as a platform, what do you want this particular offering to be platform? You decide that, and you basically, that based on the intent file, the platform will configure that for you. There are, like for example, recently I had a meeting, discussion with somebody, hyper-threading, they wanted on or off. I said the platform by default it's enabled. When the VM comes up, you can on a Nova board, you can say whether you want disable or enable. The idea is a generic platform, and any one of those VNFs should work. Now, there might be new requirements for the VNF. Yes, we'll have to work with you to see if there's a knob that we need to add to expose that feature offering.
Yeah, thank you. One of the things I want to look at it is the orchestrations on the universal CPE, right? So sure. With your VIM, it's going to be the future of the Cisco orchestration platform for the universal CPE or the edge, computing.
I think in that, this is one of those questions where we go back to the ETSI diagram almost. Again, we build a platform. The platform itself doesn't contain the orchestration. It rides along afterwards. If you want to use Cisco NSO, ESC to do your orchestration, this platform works with both of them. If you don't, then that's also fine. This is just an OpenStack platform, and anything that works with the OpenStack APIs will work with it. So that's your choice. But it's not. We're trying to build, again, that foundation on which you build. We're not trying to build the world's solution here. So if you're trying to build a CPE solution, then you can pull components from us or from Cisco or from wherever you like to choose.
Thank you.
We have one more over here.
Hi. Have you done any testing pertaining to centralizing the control plane of OpenStack with remote computes? And if you have, can you share any details on what type of latency budgets were involved between the remote computes and the centralized location, scale, HA?
Well, arguably, I mean, we chose not to do this. I think for reasons other than simply having tested it and decided it's not going to work. We chose not to do this because it's got a real problem with failure domains. It's got a real problem in general architecture terms. In the fact that it's simply a model that isn't expected to work with OpenStack and that is never going to be a core focus of the developers of OpenStack because, again, they mostly work in enterprises and in data centers. So for many reasons, we elected not to go that way. We elected to try and lighten the control plane to make sure that the control plane was something that could ride along on a small number of servers and not eat all of your computing resources. So we don't have any testing in that regard. We've just gone with this is the wrong approach to take.
We have some anecdotal evidence of what Ian's talking about. So as you know, inside our lab, we have tried to do with central Ceph just to reduce hardware footprint of the lab. We have seen like between two buildings, you cannot do storage performance on that. It just really tanks because we have tested that tool with and without that. We basically seen that even within two buildings on campus, same campus, it's not worth it. It's really slow. VM boots become very slow. So again, this is where you have to really ask yourself whether it's worth putting the effort on any of this when the technology itself doesn't support it. The underlying technology isn't supported there. So that's basically, we have some anecdotal evidence, and based on that, we basically rather go with the micropod approach, where you really anyway have a very small footprint on the edge, and think about centralizing the management to reduce the management problem.
Have you evaluated Nova cells or region-based deployment approach of OpenStack to see if that helps mitigate some of these issues you mentioned?
No, would be the simple answer. No. But again, you're drawing things back to a central failure domain with any of these approaches. If I want to make something run in OpenStack, I talk to a central API server for OpenStack. If I can't reach the central API server, I can't be autonomous. So now I've tied the life of what's happening over here to about, say 300 miles of fiber, being cooperative today, which is exactly the thing we were trying to avoid.
Okay, thank you.
Quick question. In one of your diagrams before, you had depicted an independent SDN controller in each of the edge clouds. So is the assumption then that each of these clouds are completely self-sufficient?
Yes.
So what if you have a VNF that needs to collaborate with another component in a central site? For example, I can come up with a VNF which requires some analytical capabilities, but those analytical capabilities are in a central or an aggregation cloud. So now how do you stitch these two components?
Well, so you're really asking, how do I span a network from over here to one over here?
That's correct.
And there are any number of ways of making that work. Some of the more advanced SDN work that we're doing here, it basically allows things such as spanning VXLAN from one cloud, or one cloud, yes, I mean one NFV location, to some other edge of the network. So that would be one way of spanning that across. But you know, we have to remember as well that this is a network. It's quite happy of routing. If I don't want to do this with overlays, I can actually just deal with straightforward.
So VNFs did not.
The options exist. You can do any of those.
And VNFs did not reside on the same cloud, right? As long as the networking exists, you're good to go.
Yeah.
Okay. Sounds good. That's what I wanted to understand.
Yeah.
Thanks.
I was wondering. I think that takes care of all the questions. Ian, Chandra, thank you very much.
Thank you.
We have one more session starting up in about 10 minutes. Hope you can stay around for that. And if you have any questions, obviously come down to our booth in the marketplace, and we'll see you in about 10.